All right, good people. Here we are to the last part um, for this section, and then we'll do some more of these in class the next time we meet up. Example 4, no more equation. Now we have a graph, but be very careful. What is this the graph of, and what are the questions about? So this is the graph of h prime. This is the derivative graph. On what intervals is h increasing? So the graph is about h prime, but the question is about h. So be aware of that. So in order to help me, I'm going to use my, if you understand the sign chart process, then you can just use the sign chart process. Where is the derivative equal to 0? The derivative is equal to 0 at -2 and at 1. How do I know that? Because this graph tells me that h prime, this graph, equals to 0 here, here. Oh, and I forgot 0. So let's fix that. At 0 and at 1. And that's special because all of these make the derivative equal to 0. But here's the nice part. I don't need to pick a point and plug it in. I already can see what's going on. In this part, all of these function values are positive. And then in between -2 and 0, all of these are also positive. Well, we'll use different colors so you can see what I'm talking about. These are all positive all the way to 0. And then down here, these are negative. I'm talking about the graph values, the function values, because these are the derivative values. And then over here, these are all positive. And we want to know, when is h of x increasing? Well, h of x is increasing. H is increasing here and here and here. So on what intervals is h of x increasing? H of x is increasing. Answer the question, please. On the intervals for x's that are less than or equal to 0, so all of this side, and x's that are greater than or equal to 1. Right? Those are the two places where the function is increasing. Second part, does h of x have a local min, a local max, or neither at x equals -2? Well, let's see. At x equals -2, the graph is going up, and then it's going up again. So it never changes directions. And if it doesn't change directions, well, then there's no max, or there's no min. So, by the way, what does happen there? If the function's going up, and then at -2, it's 0, but then it continues to go up, it kind of does something like this, right? Like it flattens out for one instant. It flattens out, and then it keeps going. But every y value, any y value that I pick, any two y values that I pick in this window, the second one is always higher than the first one, so it's increasing throughout. But let's answer the question. H has neither a local min nor a local max at x equals -2, because h prime does not change signs. And that's it, right? Find any x values where h has a relative minimum. Okay. Well, we know where it's increasing. By the way, it's decreasing here. Let me change to that color. It's decreasing here. I draw that only so that we can see there's a peak, there's a relative max at x equals 0, but there's a valley, there's a dip here at x equals 1, and that's where it is. So h has a relative minimum at x equals 1, and I know this because h prime changes signs from negative to positive. From negative slopes to positive slopes means that I have that dip, that valley, and therefore that is a relative minimum at that x value. And I think those are the three parts of example 4. So I'm going to be straightforward with you. Analyzing functions and finding where they're increasing, decreasing, finding their extreme points. That is definitely one of the usually the common question between BC and AB test. But there's usually a free response question dealing with these ideas. So it's important that we practice them to kind of make sure we understand the process of finding things and then how to adapt when we're given different information. For example, example 4, they gave me a graph, but it wasn't even the graph of the original function. It was a graph of the derivative, right? And that's what we'll stop here. So example 5 asks you to find relative extreme of that function. So you would follow the process. Example 6 also, but this time they give you the derivative. Example 7, which is straight from the AP exam, is asking you about increasing and decreasing and relative mins of the function, even though they don't give you the graph of the function. So maybe for fun, wink, wink, nudge, nudge, if you could do example number 7 and bring it to class for next time, we can talk about that AP problem and how it fared in 2017. Otherwise, this is the end of this section.